What if I told you that an event happening tomorrow could change what happened yesterday? No, this isn't science fiction. It's a real mind-bending concept from quantum physics called retrocausality. Welcome to the Bizarre Bureau, where today we're asking, can the future rewrite the past? Let's start with a normal Tuesday. You wake up, you go to work, you come home. Everything seems linear. Cause precedes effect. You drop a glass, it shatters. Simple. That's how we experience the world. But down at the quantum level, the very building blocks of our reality, the rules get weird. In the bizarre world of tiny particles, the neat line between past, present, and future begins to blur. The idea of retrocausality suggests that the future isn't just a consequence of the past. It might actually be one of its causes. To understand this, we need to dive into one of quantum mechanics' greatest mysteries, the double-slit experiment. Imagine firing tiny particles, like electrons, at a screen with two narrow slits. If you don't watch which slit the particle goes through, it behaves like a wave, passing through both slits at once and creating an interference pattern on the detector screen behind it. But here's the twist. If you place a detector at the slits to see which one the particle goes through, the wave pattern vanishes. The particle suddenly acts like a solid little ball, going through just one slit or the other. It's as if the act of observing it forces the particle to choose its path. This is weird enough, but it gets even stranger. Enter physicist John Wheeler and his delayed choice thought experiment, later confirmed by real-world tests. What if, he asked, we decide whether to measure the particle's path after it has already passed through the slits, but before it hits the final detector screen? Logically, the particle's journey through the slits is already in the past. Its choice to act as a wave or a particle should already be made. But that's not what happens. Even when the decision to measure is made after the particle has passed the slits, the outcome changes. If you choose to measure its path, it behaves as if it had only gone through one slit all along. If you choose not to measure, it acts as if it had traveled like a wave through both. Think about that for a second. A choice made in the present appears to have reached back in time to alter the past behavior of the particle. It's as if the particle knew what you were going to do in the future. This is the heart of retrocausality. The measurement in the future seems to be the cause of the particle's behavior in the past. So, what's going on here? How can this be possible without breaking everything we know about the universe? One leading interpretation comes from physicists like Yakir Aronov. He proposes that quantum mechanics isn't just about the state of a system now, but is described by two state vectors, one evolving forward from the past and one evolving backward from the future. Imagine a particle's journey not as a single line, but as a meeting point between a wave coming from the past and another wave coming from the future. The final measurement in the future helps define the properties of this backward wave, which in turn influences how the particle behaves at an earlier point in time. It's not that the future is changing the past, but rather that the past was never fully determined until its future was set. This isn't just a philosophical daydream. It has tangible implications. Some scientists believe that understanding retrocausality could help resolve some of the biggest paradoxes in physics, like the measurement problem. Why does reality seem to snap into a single state only when we look at it? If the future influences the past, then the act of measurement isn't collapsing a wave of possibilities. It is simply revealing the one path that was consistent with both its past and future conditions all along. Let's be clear, this doesn't mean you can go back and unspill your coffee by deciding not to spill it tomorrow. On the macro level of our everyday lives, the arrow of time seems to move firmly in one direction. The effects are incredibly subtle and confined to the quantum realm. You can't send lottery numbers back to your past self. Why? Because to get the information from the future measurement, you have to, wait for the future measurement to happen. By the time you know the outcome, the past has already occurred. It prevents any classic grandfather paradoxes. You can't change the past in a way that creates a contradiction, because the past and future are co-defining each other in a self-consistent loop. but the implications are still staggering. It suggests that time might not be the one-way street we perceive it to be. Instead, it could be a more complex, interconnected landscape where past, present, and future are linked in ways we're only just beginning to grasp. Think of it like reading a book. When you're on the first chapter, you don't know the ending. But the author, who exists outside the book's timeline, wrote the beginning with the ending already in mind. Every word in the first chapter was chosen to lead to that final page. In a retrocausal universe, the laws of physics might be acting like that author, weaving a story where the end is just as important in shaping the beginning as the beginning is in shaping the end. This radical idea is pushing the boundaries of scientific thought. Researchers are actively designing experiments to test the limits of retrocausality. Could it explain quantum entanglement, where two particles remain connected no matter the distance, as if information were traveling faster than light? Perhaps there's no spooky action at a distance. Instead, the future measurement of one particle could be influencing the past of both, creating the correlation we observe in the present. So the next time you look up at the night sky, consider this. The light from a distant star you see tonight began its journey millions of years ago. Our conventional view says its past is fixed. But in a retrocausal universe, your act of observing it now, in this moment, might be the final piece of a puzzle that completes its story. A story written forwards and backwards through time. The universe is far more bizarre and far more connected than we ever imagined. The future isn't just something we're heading towards. It might be reaching back to shape us right now. What do you think? Is our reality being co-authored by the future? Let me know your thoughts in the comments below. If you enjoy exploring the strange and unexplained, make sure to hit that subscribe button and ring the bell to join the Bizarre Bureau for our next investigation. Thanks for watching.